Finding area, part 2, when the function goes below the x-axis. What happens is you're going to generate negative area because the height of your rectangle is now a negative number and direction matters. So we are going to take that as a negative height. So for this example, our function is up here. We're going from a starting value to collect area of a equaling -4, going until b equaling 8. So I'm going to collect area from -4 until +8. So if you look at the curve, -4 is intersecting below the x-axis. I'm going 12 units, dividing it by 6 subintervals. That means each rectangle's base is going to be a width of 2. So I started off, I went from -4 to -2 for my base, went down until I'm intersecting the curve right here. I went across 2 units because I'm doing a left sum. Then I went at -2. I went down until I hit the curve at that height, and then I went across for rectangle number 2. That's going from -2 to 0. Rectangle number 3 is from 0 to 2, but I want to do the left-hand height. So on the left-hand side, it's intersecting again below the x-axis. So I'm going straight across at that height at 0 and then back up. Now notice, most of this area is negative, but there's a lot of area here above the curve. So this estimate or approximation for area is not going to be all that great because my boxes are so wide. But again, I wanted to give you a visualization on approximating area with the technique so that you could see the technique in action. We'll refine it later. The next one goes from 2 to 4. So I go up at 2, hit the curve across. Next rectangle, I'm going up at 4, hit the curve, go across and down. My last rectangle, to demonstrate it, I'm here at 6, going up, hit the curve, go across for 2 units, drop back down, and then that is my final 6th rectangle. Again, to find the area, I need to know what are all these heights. So I'm going to take and use my graphing calculator. To get to where we need to go, you're going to hit the Stat button. It is Edit, so I hit Enter on Edit. Make sure your lists are clear. If they're not clear, arrow up to L1. Make sure the cursor is on L1. Hit Clear, then hit Enter. That clears the list. Arrow up over to L2. Hit Clear. Enter, clears list 2. You want both of them clear. For the left sum, I started at the leftmost endpoint, which was -4. So I'm going to go -4, and I'm going by a width of 2. So -2, 0, 2, 4, 6. And if you notice, it says that I'm on the 6th entry to make sure you don't do too many rectangles. So I hit Enter. And now I know I am good because I have 6 entries for 6 rectangles. I arrow right and up, and the formula to get those heights once I'm on L2 is my formula, which is written in terms of x, but we put it in terms of L1. So I'm going to hit negative, and then it's 0.25 second L1 to the 3rd plus, oops, I'm using a different calculator today. Have to hit delete. If you have this model, you'd have to do that too. I'm up in the exponent. You have to right arrow key to make sure you're down. Plus second L1 squared plus 8 second L1 minus 4. Hit enter, and I get the heights of my rectangle. And so if we look, there's the heights for my rectangle. To get the summation here of all those heights, again, second quit to get to the home screen, second stat, over to math, hit number 5 for sum, summing that second list. That's the sum of the heights, times 2 gets me an area of 92 for the approximate area under this curve. That's the left Riemann sum. Next, we're going to do the right sum. And for the right sum, we're going to do 4 subintervals. For this one, on the right-hand side, if you take 12 units, divide it by 4 subintervals, that gives me a width of 3 for each base of my rectangle. So I started, and I could make my base from -4 to -1. However, the height is determined by the right-hand side. So I go down until I hit the curve on the right-hand side, then I backtrack to create my first rectangle. So this is rectangle 1. Rectangle 2, if I take -1, add 3, I'm at 2. So I figure out where the curve is at 2. I go up, I'm intersecting here. I backtrack again, I'm creating rectangle number 2. Next one, I'm at 2, I add 3, I get to 5. My next rectangle, I go up to the curve at 5, backtrack across and down. That's rectangle 3. The last rectangle is found at 8. 8 is crossing down below the axis. So I'm finding where it's crossing, so be very careful where you are. So at 8, I'm here. I'm going to backtrack and go back to 5. So this is my final rectangle. Okay. So then to find the heights for all of these, what we do is we hit Stat, Edit, go up, clear list, enter, up, over, clear the list, enter. And now for the heights in L1, I'm doing the right numbers. So my right numbers were -1, then it was 2, then it was 5, and it was 8. I notice I'm at L1 of 5. That means I have 4 entries to make 4 subintervals, so I know I didn't miss any. Right arrow key and up, and you type in your formula just like we did before. So it's going to be -0.25 L1 to the third plus L1 squared plus 8L1 minus 4. You should get the same heights as me, times 3 to get an area of 87, and that is my right sum. Last sum is the midpoint sum. So here is my midpoint sum. We're going to do that with 3 subintervals. If I take 12, break it into 3 equal parts, base length is 4. I've already got 2 of them done for you. I didn't do the first. So I'm here at -4, and I want to go to 0. So -4 to 0 is the first base. The midpoint would be found at -2. So I'm going to go down until I hit the curve at -2. That's the height I'm looking for my rectangle for the midpoint sum. I go to the right for 2 units. I go to the left for 2 units. This is creating my first rectangle. Then I'm filling it in. This is rectangle 1. For rectangle 2, it went from 0 to 4. So I went at 2, hit the curve, went 2 units right, 2 units left. That's rectangle 2. For rectangle 3, I went at 6, which was the midpoint, hit the curve, 2 units right to 8, 2 units left to 4. That is my third and final rectangle. So for this one, I have 4, because each base is 4, times the following 3 heights. And I think we've done enough now so that you got the hang of how to do these to get an area of 104. The last piece is to find the area exactly. So you can see I have started the shading in of the infinite rectangles. Because again, how do I find area exactly? I want to get infinite rectangles here under the curve and all the way up through 8. So when you get to 8, you're going to have a tiny little region here. And it gets really kind of cool when you graph it on your graphing calculator. It shows you all that same region and it fills it in. We're starting to collect area at a lower limit of -4, so I put that as my lower bound. We end the collection area at 8, so I put that as my upper bound. Inside here is how I find the height of each and every rectangle, which is my function, so -1/4 x cubed plus x squared plus 8x minus 4. dx is standing for the change in the x-axis, which is going infinitely smaller and smaller. It's approaching 0. So you have height of the rectangle times the width. So we go to the graphing calculator, go to y equals, clear out anything you have. We type in the -0.25 x to the third. Then we have plus x squared plus 8x minus 4. Zoom 6. Now I'm not seeing everything. I could change my window, but I think you'll see most of it, so I'm just going to go on with this. I'm going to hit second trace to get to that calculate menu, because that's how I find my antiderivative or my area. Option number 7, so I hit number 7, and it's asking me for a lower limit. The lower limit in this case is -4, so I type -4, enter. It's asking me for the upper limit. Where do I stop the collection of area? That is at 8, and I hit enter. And it fills in. So you can see it filling in, and even that tiny little area over here. So not quite all of it, because the -4 starts here, and then all the way to the 8. And then the area exactly is 96. So I would say equals 96 for total area. And that's it for lesson 6-1, day 2.